Hello viewers. So today we will discuss one of the important topic of CSIR NET syllabus, that is gene mapping, that is linkage mapping problems. Many previous year it is repeated. Many questions are repeated in this topic. So we'll solve that previous year question paper. So first question: in a linkage map, two genes A and B. In a linkage map, two genes A and B A and B are 70 centimorgan apart. A and B are 70 centimorgan apart. If individuals heterozygous for both the genes are test cross, number of progeny with parental phenotype will be equals to the number of progeny with recombinant phenotype. Generally, we know that the recombination frequency, maximum recombination frequency is greater than 50%, almost 50%, and so if the recombination frequency here is 70 centimorgan apart, so it will be equal to the number of progeny with recombinant phenotype. Now, next question. In a cross, a cross was made between pure wild type males and brown-eyed curled-wing females of Drosophila melanogaster. The F1 females were test cross. The F2 progeny obtained was as follows. Now we know that the wild type, the we know that first you have to find out is non crossover frequency or parental combination. First you have to find parental combination, parental combination or NCO, non crossover, parental combination or non crossover product. What will be, how will you identify the maximum number, whichever given in the maximum number is the parental combination. The wild type here is a, so 200, and brown white curled wing is 150. So parental combinations are 200 and 150. Now you have to find recombinant product. Now these two are recombinant product. Recombinant product. Now we know that these are total number. So we know that the in case of recombination frequency or map distance, recombination frequency equal to number of recombinant, number of recombinant, number of recombinant, number of recombinant by total number of progeny, by total progeny, number of progeny into 100%. So here, so recombinant product is 30 plus 20. Now total number of progeny is 400. So 400 into 100%. Now we'll get 50 by 400 to 100%. Now we'll get 12.5, 12.5% or 12.5 centimorgan, right? Or map unit, 12.5 map unit. So in that way you can solve. So answer is the 12.5. So what's actually you have to do? The find the parental combination. What's the wild type? Maximum number is given. Then you have to find the recombinant one. Recombinant are lowest number. So here you will get recombinant. These two are recombinant progeny, 30 and 20. So we know that recombination frequency, or you can say that genetic map distance, genetic map distance map distance equal to number of recombinant by total number of progeny into 100%, right? So answer is 12.5. So next question. Now here in a Drosophila bari is a dominant mutation, while miniature wings and yellow color is are recessive. These are three genes are given. That's called 3-point mapping, and previously you have seen the 2-point and mapping. So here now BMY. Now here is the way is that first find out the parental combination. So steps is first find out parental combination, parental or NCO non-crossover frequency. Now second is find the DCO1, DCO or double crossover. Third is the find middle gene, find the middle gene. After getting you the middle gene, arrange the gene order. So arrange according to gene order. Then this is a fourth, then fifth, get the single crossover frequency. Get SCO1 and SCO2, single crossover 1 and single crossover 2. In that way you have to do say single crossover 1, single crossover 2, right? Then you can do that. After getting the single crossover, you can calculate the map distance between two genes, right? SCO1 and SCO2, and then from here you can next you can calculate, though this question is not asked, interference. Then you can calculate COC, coefficient of, first you calculate coefficient of coincidence, then interference, because interference equal to coefficient of interference. So find first find coefficient of coincidence, then find interference, because interference equal to 1 minus COC, 1 minus coefficient of coincidence. Now coefficient of coincidence equal to observed frequency of DCO by expected frequency of DCO, right? Now see that question, what's actually asking in that question. Now first we will see that question. So first find out here, what's the maximum number of progeny, maximum number, which one given the maximum one, right? So first is find the maximum one, find maximum one. So what's the maximum here? Maximum is that here is 185, that is b plus m plus b plus m y. These are maximum, we say 185 b 160 b m plus y plus 165. These two are parental combination, parental or NCO non crossover, right? This two is done. Now find out the SCO, find out the DCO. Sorry, DCO1 double crossover. So what will be the double crossover? Double crossover are lowest frequency. So lowest is here 20. So B M Y equal to 20. Now B plus M plus Y plus equal to 30. So these two are DCO product, double crossover product. Now how we will get the middle gene? Now we are finding the middle gene. Now you are trying to find out the middle gene. So what will be the middle gene? Middle gene equal to, so first is compare. You compare with B plus M Y, that is NCO product, plus NCO product plus, these are now compare with B M Y, double crossover, that is 20. So these are DCO. So whatever the changing, these are the middle gene. So here B is the middle gene. Here B is the middle gene. Middle gene. B is the middle gene. Now, so one option you will get. So arrangement will be M B Y. The gene add based on the result obtained, the gene will be BMY. You have got one. Now you have to calculate the genetic distance or map distance. Now we'll calculate the map distance. So for map distance calculation, so first of all, you have to now arrange according to gene order M, B, Y. Another is the given is M plus, see that M plus M, B, parental combination are M, B plus M, Y, B plus, so M, B plus M, B plus Y, one will be M, B plus Y, parental one, M, B plus Y, M plus B, Y plus, right? M plus B, Y plus, parental combination, just arrange according to middle gene. So middle gene is B. So M plus B, Y plus. Another is the M, B plus Y. Right? See that combination? These two are highest number. These two are highest number. M plus B, Y plus. We have written M plus B, Y plus. Another is the M, B, Y. Now we'll get the distance. Now we have to find out the map distance between what? Map distance between B and Y. B and Y. Now we'll calculate B and Y. So if you have calculate between B and Y, so now we're creating crossing over. Now, what will be the read it according to arrow? So, what will get the progeny? M, B plus, Y plus, another is the M plus B, M plus B, Y. Right? Now, get the number. What is the number of M, B plus, Y plus, another is the M plus by. M plus by, it is 110. M plus by 110. M, B plus Y plus 120. So see that M, B plus Y plus, M, B plus, M, M, B plus Y plus, M, B plus Y plus, these are 120. Another is the 110. B, M plus Y, right? These are two. Now how will get the map distance? So distance between, so map distance between B and Y gene, B and Y gene equal to, Now we got 120 plus 110 plus, now whatever the DCO number, you have to add the DCO. So DCO is your here 20 plus 30 is that DCO by total number of progeny. So here total progeny is, total progeny you will get, now add the total progeny. So here we'll get 700 total progeny. If you add total progeny, so 30 plus 30 plus 25, 30 plus 25, and here you will get 55, 55, 165, 125. Now 1 2 3 4, 400, 500, 600, 700. So you'll get total 700, right? So total progeny is, number is 700. 700, 700 into 100%. Now here is 120 into 120, 230, 120 plus 100, 220, 230, 230 plus 50 by 700, 7 into 700, so 280 by 7, 280 by 7, so 40 centimorgan. 40, first is 40%. 1% we know 1% is equal to 1 centimorgan, right? So 1% is equal to 1 centimorgan. So here we will get the 40 centimorgan. So answer is 40 centimorgan distance between. Now if you want to get distance between these, distance between M and B. Now for M and B, then how we'll do that? Same way, just if you want to do M and B, distance between M and B. So in case of M and B, if you want to get distance between M and B, M B plus Y, and other is the M plus B Y plus, though question paper do not ask that, but it'll, I'll show you. So first is that, so M, just put the arrow according to the, here is the distance between, distance between between M and B, between M and B gene. M and B gene will be, so first is that you will get progeny. Progeny is M B Y plus M B, just come in that arrow, M B Y plus M plus M plus B plus Y, M B Y plus M plus B plus Y, right? M B Y plus M B Y plus M plus B plus. Now you will get that number from the table given. From here you will get the number, and according to M plus B plus Y, M plus B plus Y, it is 45. M plus B plus Y is given 45. 45 M plus B plus Y, M plus B plus Y 45. Now Y plus, now 45. Now M B plus M Y plus, or B M Y plus is 25. B M Y plus, so according to, you will get that. So M plus B plus, now we will add the DCO one, and then we will get the map distance between M and B gene, right? Now next question. So in a popular dioecious plant, A, B, C genes, three genes are given. Three genes here, A, B, and C. Now this question we will do. A, B, and C genes are given. So first of all, what you have to do now, first is find the NCO product or non-crossover product, non-crossover or parental combination. So first find NCO or parental combination. Parental combination. So what's a parental combination? Parental combination are highest number. So find out the highest number, 300 and 300 and 310, right? So just for simplicity, I'm writing A, B, C, 300, and small a, small b, and small c is 310. Now, find out DCO1. DCO is 16 and 14, right? 16 and 14. So DCO will be small a, capital B, small a, capital B, small c. Another is the capital A, small b, capital C. So here is 16 and another is the 14. Now, now you have to find out the middle gene, right? So middle gene here will be, what will be the middle gene? Now, capital A, capital B, capital C, small a, small a, capital B, capital C. So A is the middle gene, right? A is the middle genes. Now, how will get the map distance between A to B gene? Now you will have to calculate the map distance between A and B gene. Map distance between A and B gene will be, now here is that, first of all, the find the A and B gene. Now if you arrange B, A, capital C, small a, small b, small a, small c. Now between A and B, what will be the progeny? B, small a, small c. Another is the capital small b, capital A, capital C, right? So capital B. Now here you have to just assume that the first of all 120. See that 120 is a total one. This is a 120. So capital A, small b. So two recombine, these two, one is 120. So recombined product. First of all, here you see that recombined product. Recombined product. Recombined product. If it is a, you got the parental. This one parental combination. This is a parental combination. This one DCO combination, right? Now rest of the one are recombined one, because here the data is given some a, so different way, hybrid way. So you have to, now this one recombinant one, this one recombinant one, another recombinant one is 65 and 75, right? So add that recombinant one. So recombination between A and B gene, A and B gene will be, so first is 100 plus 120 by, this is a total is 1000. Total number of progeny is 1000 into 100%. Now 100 plus 20 we will get here 220 plus 1000. Now 1000 you will cut, so here you have 100. So just do that, you'll get 100. So this two gone by 10, so you'll get 20. Oh, you have to add also the DCO product. DCO combination are 14 plus 16. You have to add. If you do not add DCO, you will get 22. So you must have to add DCO one. So 100 plus 120. So map distance will be 120 plus 14 plus 16 by 1000 into 100. So here we will get 250 by 1000 into 100. Now we'll get 25. So 25 map unit is the answer. So one is the 25 you got. Now next is you have to find out between A, B and C gene. Now for B and C gene, so these are 65 and 75. Now for B and C gene, for B and C, B and C gene, distance between B and C gene will be, first add 65 plus 75 plus 14 plus 16 by 1000 into 100%. Now here is 60, you'll get 30 here, and from here you will get 140, right? Now by 1000 into 100%. So 170 by 10, 17%. 17% equal to 17 centimorgan or 17 map unit. So answer is option 1 is the correct answer. So answer is 25 and 17 map unit respectively. Now next question. Now here is that you have to go in a dish. Here in a 3-point test cross was carried out in Drosophila melanogaster involving 3 genes adjacent X, Y and Z. Now arrange in the same order. The distance between X and Y is 32.5 map unit. Now 3 genes are there, X, Y and Z. Now distance is given, X and Y 32.5 map unit. X and Y, distance between X and Y is 32.5 map unit or 32%. You can say that 32%, 32.5%. Another is the Y and Z is 20.5 map unit or 20.5%, right? Now we know that, okay, now we know that um, we know that coefficient of coincidence here is given, coefficient of coincidence. So according to, we know that we know that coefficient of coincidence or COC, coefficient of coincidence, coefficient of coincidence, coefficient of coincidence, coefficient of coincidence or COC equal to observed frequency of DCO by expected frequency of DCO. Observed frequency of DCO, observed frequency of double crossover by expected frequency of double crossover. Expected frequency of DCO. Now, observed frequency of DCO. Now, observed frequency, whatever the given in the question paper, these are the observed frequency. Now, we have to calculate the expected frequency. So, expected frequency of DCO, expected frequency of DCO equal to single frequency of single crossover, frequency of SCO1, single crossover 1 frequency into single crossover 2. Now single crossover 1 is given 32.5. Now put that 32.5%. Now 32.5% we can write in that way, 32.5 by 100. Another is the 20.5%. So 20.5%, 20.5 by 100. Now here you will get 0.066625%. 25. This will come that, right? Now we calculate the observed frequency of, now observed frequency of DCO. You have to calculate the what is the percentage of double crossover in the progeny. Acha, what is the double recombinant in the progeny obtained from, right? So you have to calculate the observed frequency of DCO. Now here is COC is given, so COC is the value is given 0.886, 0.886 is given already. Observed frequency of DCO. Now observed frequency of DCO, observed frequency of DCO by expected frequency. You have got that 0.066, 0.06625. Now so observed frequency will be observed frequency of DCO, frequency of DCO equal to 0.886 into 0.06625, almost it will come 0.05920. This calculation without calculator, so this is difficult, so it will come 5.92% equal to 6%, almost equal to 6%. So answer is option 1. So whatever we have done here, so first is that a 3-point test cross. So first map distance is given between three genes are there, X, Y and Z. Now X and Y distance is given 32.5 map unit or 32%, Y and Z 20.5 map unit or 20.5%. Now we know that the formula COC or coefficient of coincidence equal to observed frequency of DCO by expected frequency of DCO. Now here observed frequency of DCO, observed frequency of DCO, you have to calculate the observed frequency of DCO. Here COC is given, COC coefficient of coincidence 0.8886, right? Observed frequency of DCO, observed frequency of DCO, you have to find it out, because what is the double recombinant progeny in the test cross. This is how you have to find out the observed frequency of DCO. Now here you will get the expected frequency of DCO from single crossover 1 into single multiplying single crossover 2. So 32.5 into 20.5 by 100. So from here you will got that observe expected frequency of DCO. Now you'll get observed frequency of DCO is almost 6%. So hope that makes clear. Thank you.